So what's the problem say?
So an airplane trip involves four legs. The first leg is 30 degrees north of east for 200 kilometers.
Okay. So I'll just kind of write this information down. So we've got one leg. So it's 30 degrees north of east.
Yeah.
For how long?
For 420 kilometers. Yeah.
Okay.
km. And then you have the second leg, which is 60 degrees north of west for 280 kilometers.
280 kilometers?
Yeah. And the third is 22 degrees south of west.
Okay.
And it has the magnitude of 320 kilometers.
All right.
And the fourth leg, it states that it has a 35 degree angle east of south for 210 kilometers.
Okay. So what are these kind of giving you the idea of?
They're going to be on separate quadrants.
Yeah?
Each one will be on a different quadrant.
Okay. So if we were to try to draw these would be when you have a magnitude and a direction, it means you have a vector, right?
It means you have a vector, yes, that too.
So each one of these is a vector.
Mm-hmm.
So let's get an idea of kind of what these vectors would look like. If we've got number 1 up here, we draw our compass points.
Yes.
So what's our first vector going to look like?
The first vector is going to be north towards east. So it's going to be on the first quadrant.
Yep. And where's the angle going to be relative
30
to?
degrees, which is less than halfway.
So it'd be kind of like this, right?
Yes.
The distance of 420.
Let me draw that. 30 degrees, 420 km. Okay.
All right. What's the next one kind of look like?
It's gonna be at the, let me see, southwest second quadrant, northwest second quadrant, and it's
Okay. So here.
yeah, and 60 degrees. It's gonna be like more than halfway.
So it'd be kind of, that's about, well, we'll go ahead and go with that. It doesn't have to be perfect. 280 kilometers. It's going to be 60 degrees.
Yes.
Okay.
260. Oh, no, my bad. 280.
Let me make this a little shorter to make it more to scale with our first one here. Okay.
Good. Then the next one will be in the third quadrant, I believe.
So south of west.
Yes.
So north, east, south, west. So it's going to be in this.
Yes. It's 22 degrees, so it's going to be a pretty short angle, like pretty close to the x-axis.
Kind of something like that, right?
Yes.
22 degrees. 320.
Mm-hmm. And let me see. 320. 22 degrees. And then the last one will be in the fourth quadrant, will be 35 degrees, so just a little less than half.
So east of south. And which, so a little less than half, but which way?
Which way? Oh, from the x-axis, from the...
So this one you got to watch out with. Most of these, you've been going south or north of, so you've been going towards the y-axis from the x-axis.
Yeah.
What does it mean when it says east of south?
You made a good point. It's going to be more towards the y-axis.
Right. So you want to make sure that it's going to be 35 degrees, so something like this, right? That angle.
Yeah.
Oh, and this would be pretty short still. Is that kind of what you were thinking?
Yeah, that's what I was thinking now. Now that you brought that up. Okay. Very good. Go to 20. Go to 10 kilometers.
So then it says the first thing you should do is solve it graphically. So using like a graphical approach.
This is right here. Using a graphical approach, determine the resultant displacement vectors. Vector. Note, please draw the graph on the back of this page. Whatever. Yeah.
So I think for the sake of time, it's kind of hard to, like, the longest part of that is drawing the scale, right?
Mm-hmm.
But so I've got these kind of laid out differently. You've got them all set next to each other. But how do you go about adding up all these vectors?
Adding up all of those.
Mm-hmm. Because it's not that the plane starts at the origin every time and goes out, and then comes back to the origin and goes out, right?
Could you rephrase your question?
So what would the actual path of this plane look like? We know what the vectors each look like, each section,
Yeah.
but what would the full path look like?
It looks like, I don't know, my opinion, looks like it's going around like a circle.
Yeah.
Following the vectors is going in a circle.
So let's make a kind of a big graph here. This is sort of what it's asking you to do.
Yes.
North, east, south, and west.
Mm-hmm.
And let's just put these vectors, with each other. So it starts at the origin. We can say it starts at the origin.
Yes.
First thing it does is it goes 420 kilometers, 30 degrees north of east. So that's our first section, right?
Mm-hmm.
Now what do we do with this vector?
You go to.
So we want to see the actual path of the plane. So we can draw it here, right? Like we did in the picture, we can draw it right there.
Yeah.
Where would give you a better idea of what the plane is doing?
I'm not sure.
So what if we know that the plane starts here and it goes to here,
Yeah. Yes.
and then it makes a change, right?
It makes a change.
And at this point, this is where it starts going 280 kilometers
Okay.
north of west. So let's just draw kind of a little imaginary axis here to get our angle right.
Yes.
And we have this going 280 kilometers.
All right.
That's 60 degrees
60 degrees. Okay.
north of west. And this is still true, right? This is still 280 kilometers north of and 60 degrees north of west. Even though it doesn't start at the origin,
Mm-hmm.
it starts out here. It's still the same vector. That's the great thing about vectors, is that unless you tie them down and you say that they start at the origin, you can move them around wherever you want.
All right.
So what about the third vector?
It's gonna go west towards the south.
Mm-hmm. So where do we want to put the tail of that one?
You're gonna put the tail of that one going like
Attaching from here.
attaching from that point and dragging it down.
So let's draw another
Dragging it west southward.
kind of little imaginary axis, and we know that it looks like
That.
this.
Mm-hmm.
This is 320 kilometers at an angle of 22 degrees south of east or of west.
22. Okay. And then you do the final one where you connect, where basically you're connecting that the 320 vector to the 420 vector. Or you're not connecting it, you're just extending it far.
Yeah, we're kind of extending it in that direction, but
Yeah.
we can't say for sure that it will connect.
Okay.
And in fact, if you look at the angles here,
Yes.
this one's at a 30-degree angle and it's 420 kilometers.
Mm-hmm.
And then this one is a 280-degree, or is a 60-degree angle and it's 280 kilometers.
Yes.
And then this one doesn't quite. So what we know is that because this angle is a little smaller than this angle, this distance right here has to be longer than this distance, I think.
That would make sense, yes.
But, so we don't know for sure that it connects, but we do know that
That it extends towards that
it
direction.
kind of goes this way, right?
Yes.
It's 210 kilometers at an angle of 35 degrees.
Mm-hmm.
So you're right, it does kind of go in a circle. And then what would the
Displacement.
resulting displacement be on this graph?
It would have to be the end of the fourth vector towards the beginning of the first vector.
Right, yeah. So if you drew this
Imaginary line.
this little line,
Yeah.
that would be the displacement. You're exactly right. And a
Mhm.
displacement doesn't really have a direction
Right.
because it's just a magnitude.
Until
So-
you find the angle, right?
Yeah. So if you wanted to draw a displacement vector,
Mm-hmm.
you can find this distance and it'll just be some magnitude, right?
Some magnitude.
Say it's 50 kilometers.
But then you have to find the direction.
Then it becomes a displacement vector and you actually want to draw it this direction.
Okay, so you want to. How come you want to drive towards that direction, not towards the other way?
Because if you flip it the other way,
Uh huh.
okay, so let's bring it over here. So this is our displacement vector, right?
Yes.
If you turn it around this way,
That's a negative.
right, and when we put this displacement vector at our origin, which way does it go?
It goes to 0.
So it would come and turn this way, right?
Oh, that would be the result of that.
Right. So your displacement vector has to start at your starting point and connect to the next vector. So if you make it a negative, like this, then it's actually starting here and going down.
Yeah, correct. Okay.
So, like I said, this isn't an exact graph because we didn't have the scale for it, right?
Right.
But you can draw a pretty, not necessarily a perfectly exact graph,
Mm-hmm.
but you can do it pretty,
Descriptive.
yeah, pretty descriptive, pretty much to scale using graph paper and a ruler and protractor and stuff.
Okay, yeah.
And then, what do you think that you'd have to do to find this displacement vector?
Well, from starters, I believe that you have to turn that into a triangle. Like
Yeah.
try to turn it into like some sort of right triangle.
So right here, you have to find this triangle.
Yep.
And then you know where you're starting right here.
You already know. So all you need to do is find the x and the y values
so then
for
you can-
the first vector.
So then you can draw another triangle and solve it.
Let me
And then
just draw
another
that.
triangle out here and solve it. And another triangle out here and solve it.
Yes.